All right, now that we know that most reactions are between nucleophiles and electrophiles, we know that it's important to identify the difference between the two. So remember, nucleophiles are negative or positive loving because they love the nucleus, and so they themselves are negatively charged. And vice versa for electrophiles. Electrophiles love the electrons, which are negatively charged, and so they themselves are positively charged. You can see it's easy to mix up the two. And so remember, nucleophiles are negatively charged, and so we can have different types of nucleophiles. We can have some carbon-based nucleophiles. So for example, if you have carbon bound to essentially some kind of metal, you're going to have a partial, if not full, negative charge. So these lithium compounds we'll see a good bit later on. And then we'll see MgX, where X is equal to chlorine, bromine, or iodine. These are called Grignard reagents, and they'll be very important in synthesis later on as well. Or we can have a full-on carbon negatively charged, right? A carb anion. And so those are all examples of carbon-based nucleophiles. We can think of non-carbon-based nucleophiles as well. For example, if they have some kind of lone pair, they can be nucleophilic. So if we have an alcohol right there with a lone pair, or maybe it even has a negative charge on it, right? If this alcohol, or if this alcohol is deprotonated, it's going to have a negative charge, so it is also going to be nucleophilic. It doesn't just have to be oxygen, could be other atoms such as sulfur, or maybe a halogen like a bromide. Remember, halogens don't form more than one bonds. So if you see something that's like this, right, even though it has lone pairs, it's not really nucleophilic. It's only nucleophilic when it's by itself because, again, halogens form one bond. The last thing we kind of want to think about here is pi bonds. Pi bonds are also often nucleophilic. Right, so we've got a pi bond here, and that's a little bit hard to see, but if you think about what's going on here, we have these orbitals, and there's electrons in here, and so there's a lot of electron density, and they can indeed behave as nucleophiles. And then on the other side, we have our electrophiles. Carbon is more often than not an electrophile, and your nucleophiles are more often than not heteroatoms, but that's not always true. You can have mixes and matches, right? So if you have carbon bound to any electronegative atom, such as a chlorine or any halogen, right, it's going to experience this partial positive charge, or maybe it'll be double bonded to an oxygen. That's a carbonyl. We'll see a lot of those later on. And so these carbons are all obviously partial positively charged due to the inductive effect. And then, of course, we can have a carbon with a straight up positive charge, a carbocation. That will also be electrophilic as well. So those will be our main types of nucleophiles and electrophiles. And you want to be able to look at a molecule and identify whether it's electrophilic or nucleophilic, or sometimes there'll be a combo of the both, right? It'll be nucleophilic here, electrophilic there.